Hi, everyone, and welcome to this episode of Crowded Beaker Solves. Today, we're going to do another mole conversion, except this time, we're actually going to be predicting how many atoms are actually in a sample based on how many moles it has. Believe it or not, it is possible to predict how many atoms are in a sample based on how much of it you have. The great chemists who have gone before us, including, and most notably, Mr. Avogadro, figured out ways to count atoms, and we group them, we bundle them because they're so small, we bundle them into groups called moles. And a mole has a value, and it's the same for any substance that you're counting the molecules of. In the same way as a dozen eggs and a dozen golf balls, are you still counting the same number of things? You can think of a mole as just a really big dozen. And it's really big. It's actually 602 sextillion, or 6.02 times 10 to the 23rd atoms or objects that you're counting. So I have here in my frame of view a little sample of aluminum. And this sample of aluminum weighs just about 27 grams. So this represents actually a mole of aluminum. And so in this mole of aluminum, in this sample of aluminum, there are 6.02 times 10 to the 23rd atoms of aluminum, to the best of my ability. Okay, and that's the same for every element. So let's get into the problem. The first one that we have here is that what if I had 5.33 of these sitting around, and I want to know how many atoms that is. So it's more than one mole, so it's more than 6.02 times 10 to the 23rd, but it's 5.33 of them, so bundles of them. So the way we're going to set it up is, as always, with a unit conversion, you're going to start with what you have, what you know. So we'll write down 5.33 moles of aluminum. And then, even if you're not sure what to do next, you're going to set your conversion factor up and put moles on the bottom, because we want that to go away. And we're actually, according to the problem, counting the number of atoms. So let's put that on the top. And we'll squeeze in aluminum there. And we want to know how many atoms are in a mole. And what we're just going to have to do is remember that number, which is a really big number. We'll put it in scientific notation. 6.02 times 10 to the 23rd. Probably should have given myself more room. And it's that many atoms of aluminum. And I have 5.33 bundles of those numbers of atoms. And so my calculator, after I punch it in, 5.33 times this gives me 3.20866 times 10 to the 24th. Now, I probably shouldn't put all those digits. I only have 3 digits here and also 3 digits in this coefficient. The 1 is an exact value, so let's just end with 3 digits over here. 3.21, I'll round that up, times 10 to the 24th. That's how it appears in my calculator. So you're going to get a ridiculously huge number whenever you start counting atoms, for the most part, because atoms are so tiny. Even a small sample like I can hold in my hand has just billions upon billions, trillions of atoms in it. And so we get this very large number at the end. Okay, it's your turn. And I will put the second one over here. This time we're dealing with manganese. And even though it's manganese, it's a different element. The number of atoms in a mole of manganese is the same as the number of atoms in a mole of aluminum. So take a moment, pause the video, try to figure out how many atoms of manganese are in 0.337 moles of manganese. Okay, and I'm hoping you were able to do that. And if you did, you should have ended up with 2.03 times 10 to the 23rd atoms of manganese. Again, a giant number. 0.337 times that same number, only it's manganese this time. I did get more digits than I needed, so I did round it back to 3 digits because that's my number of significant digits that I started with. So there you have it, a moles to particles conversion. Hope you enjoyed it. If you have any suggestions of problems you'd like me to solve, please include them. And in the meantime, happy solving and have a great day.